Last time we started to talk about glaciers and how these masses of ice formed from crystallized snow. And some of you may ask how should some of these glaciers are. Now, even though it may be difficult to understand how a huge massive ice, it's really no secret that the glaciers know because of the gravity, but how they grow, the way basal strip. Basal strip or sliding as is called basically refers to the slipping or sliding of a glacier across bedrock, actually across the thin layer of water on top of the bedrock. So this process shouldn't be too hard to imagine. What happened is that the ice of the base of the glacier is under a great deal of pressure. The pressures are coming from the weight of the overlying ice. And you probably know that under pressure, the melting temperature of water, the ice, is reduced. And so ice at the basis of the glacier melt even though it's below 0 degrees Celsius. And this results in thin layer of water between the glacier and the ground. This layer of water reduces the friction. It's like a lubricant, and it allows the glacier to slide or slip over the bedrock. Okay. Now the next type of movement we will talk about is called deformation. We already know that the ice is brittle and also plastic. You can change the shape without breaking. If you leave, for example, a bird over the ice supported on only one end, then supported end will deform under its own weight. Thick deformation has very slow oozing. Depending on the stresses on the glacier, the ice crystal was reorganized. And during this organization, the ice crystal realized, in a way, slide past each other and the glacier oozes downhill without any ice actually melting. Now, there are a couple of factors that affect the amount of deformation that take place. For example, deformation is more like occur at the thicker ices because of the gravity of the weight of the ice, and the temperature also plays a part here. And the cold ice does not move visually as ice cruise melting points. In fact, it is not too different from the wet oil. It's thicker at the lower temperature. So if you have a glacier in slightly warmer region, it will flow faster than the glacier in the cooler region. Okay. Now I'd like to touch briefly on extension and compression. Your textbook includes the other types as a particular type of glacial movement, but you'll see that there are codes omitted as a type of movement as included. And I might not include right now if it's in the textbook. But basically, the upper parts of glacier have less pressure on them, so they not be formed easily. They tend to be more brittle, and crevasses can form in this upper layer of the glacier. when the glacier comes into contact with bedrock walls or these otherwise and some kind of stress, but it can deform quickly enough. So the ice would expand or constrict, and that can cause big fissure. And that brittle surface is moving is sometimes considered a type of glacial movement, depending on which source you can solve. Now, as you probably know, glaciers generally move really slowly, but sometimes they experience surges. And during these surges, in some places, they can move 3 feet as high as 7,000 meters per year. Now, our speed arrives at a pretty unusual hundreds of times faster than the regular movement of glacier, but you can actually see glacier move during these surges, though it is rare.